Okay, so today we need to recall some Algebra 2 stuff about quadratics. Yay! Which should be really chill. Okay, so first, what is a quadratic function?
One with the highest power is 2.
One where so a polynomial where the highest power is 2.
Does that mean it's 2 degrees? Is that what I remember?
That does mean it's degree 2.
Cool.
So, for example, a quadratic might look like ax squared plus bx plus c. Okay. What are the restrictions on a, b, and c?
It can't be 0.
Which one can't be 0?
A can't be 0.
Okay, a can't be 0 because if a is 0,
Then it's not a quadratic.
Then the squared doesn't have a function.
yeah, then the squared really shouldn't be there, right? And you're looking at not a quadratic but a line. You guys with that? Okay, so it has to actually have the x squared part to be a quadratic, which is really all this restriction a is 0, a not 0 is saying. And how about b and c? Any restrictions on those guys?
Those are all reals.
Yeah, those can be whatever the heck. Okay, so specifically, just a can't be 0. Okay. Do you guys know what this is called? This form of writing a quadratic down.
Standard form?
Yeah, good.
I was going to call it the parent one. Is that the same thing? The parent formula? Is that something that I remember from elementary school?
Not a word I know.
Well,
It's entirely possible that other people call this something like a parent form.
yeah.
Standard form is, I think, the usual nomenclature,
Okay.
but
Yeah,
whatever.
That's what I remember. Standard is definitely.
Okay, so how else could I write this down?
Right. C plus bx plus ax squared.
Okay, up to algebraic rearrangement of just order, right? Like up to commutativity of addition. How else could I rearrange this?
There's stuff on the side.
Don't do that.
In the quadratic form?
Oh, you factored it.
Quadratic form.
Yeah, I could factor this maybe, right? So, if I could factor this, there might be a factored form, right? Which would be q of x is, what's that look like once you factored it?
Two binomials.
Exactly. 2 binomials. So it's going to be like it's going to be a plus b.
Ax.
It's going to be a plus x times b plus times x plus c. No. Where's the b? A times c is b.
Okay, so you have to be a little careful, right? Because some of the variables are going to be a little different, right?
A plus x.
So
X plus c.
I think I don't necessarily want ax and x here.
You don't want that.
I don't necessarily want that. So I'm going to put this in what's called a kind of general factored form. So I'm going to pull the a out here.
That makes so then you have x.
And then I'll have something that looks like x squared plus something. It won't be actually b, right? But something like b. And something like c. And then if you factor this, what does factoring a x squared plus stuff look like?
It's just x.
Yeah, just like an x and an x.
Yeah. And then you add b.
And like some stuff in here.
Yeah, you can't really say b if you're c, really.
Yeah, because they're not really b or c, right? They're related to b or c.
Yeah.
But what are they?
They're numbers.
They're numbers which are specifically
Real numbers.
good. They're specifically real.
Well, they're positive.
What is
Not
the?
necessarily.
How about what is the graphical interpretation of those two numbers?
A point.
Like if you had, for example, if you had q of x
They're the
is
opposite of what?
3 times x minus 1 times x plus 2.
Yeah. What are negative 1 and positive 2 in that?
Yeah, what are negative 1 and positive 2? Maybe what are positive 1 and negative 2 doing?
That, those are the zeros.
The intercepts?
Yeah, those are the
X-intercepts.
x-intercepts, right? Those are the zeros of that polynomial.
Yes.
You guys with that?
Yes.
So this would be like x minus z1 and x minus z2, with the minus signs kind of built in. Then z1 and z2 are the zeros. You guys with that? Okay. So what are the restrictions on those guys?
They can be all reals. I don't know.
Yeah, the zeros could be wherever, right? So z1 and z2 could be real numbers. And a should be
Bigger than 0.
close.
Anything but
Something with 0, right?
Can't be 0.
Specifically, it shouldn't be 0 for the same reason that it shouldn't have been 0 before. Notice that a is the same a. You guys see that? Could you get a formula for b and c based on this thing?
Maybe.
You guys see that there's definitely a relationship between b and c and maybe a and z1 and z2? How would, if you multiplied this thing out, right?
Oh, C would be negative Z1 times negative Z2. And B would be negative Z1 plus negative Z2. Is that right?
I think the c term here should be a times z1 times z2,
Multiple.
right?
Yeah.
Should be the one without any x's in it, right? And then middle term b we could figure out by FOILing this out and collecting all the terms with the x's in it. You guys all kind of with that? Okay, so that's giving me kind of yet another thing. Oh, which I need another color for. So that's getting me a way back and forth between these two, right? So to go from a factored form to a standard form, what do you do?
Well,
Yeah. FOIL and collect like terms. And to go the other way, to go from a standard form to a factored form,
you factor.
you factor. You guys cool with that? Okay. Now the other one is maybe new. The other one is vertex form, which is q of x is, okay, and this one's going to look the freakiest, but also be the most familiar today, because we just did a bunch of shifting rules stuff, right? So my claim is that you can get to any old parabola at all by thinking about it as a vertical stretch, a horizontal shift, and a vertical shift. You guys kind of with that?
Good.
So I have here a vertical stretch, a horizontal shift, and a vertical shift. So thinking about getting a parabola somewhere, right? To get a parabola to be somewhere, I need to know how steep it is, and then I need to scoot it left or right and up or down. So I've got how steep is it, how far right did you scoot it, and how far up did you scoot it. You guys kind of with that? So what are the restrictions on the variables in that one? The a, the h, and the k.
The A can't be 0.
Okay. A can't be 0.
The H and the K are probably all real numbers.
And the h and the k can be whatever. Okay, where'd I lose you guys? Where'd I lose you?
You were just
I was trying to remember, you said them and I forgot them.
Oh, the pieces?
Yeah.
Yeah, so this is a vertical stretch and maybe a flip, right? If A is negative, that would include a flip too. H is a right by H. Plus K is an up K, right? So if I add a negative K, instead of going up K, it'll go down K. well, down minus k, right? It'll go up minus k, which is down by the absolute value of k. How about that for precision? Okay, so where's h and k here? What's the important thing about h and k there?
Is that the vertex?
Yeah, that's the new vertex. So this guy is the new vertex. Or the vertex, I suppose. Okay, so that's the vertex. What are z1 and z2? Those were the
Zeros.
zeros. I don't know how to spell zeros. Put an e in there?
Z-E-R-O-E-S.
Like that?
Yeah, that's right.
That looks super dorky.
Like heroes.
Okay. Question. What's your guys' question?
I have a question. Why
Yes,
is
hit
there
it.
why is it minus h?
Because I wanted to think about it as going right by h.
Okay.
And the x shit's all backwards, right? So I want to put it in the spot I think about. So I want h comma k to be the vertex, not minus h comma k. If I had a plus sign in here, it'd go left, and then minus h comma k would be the vertex.
So it's just for the sake of this.
It's really so that this thing is the h comma k is the vertex. And the reason I'm doing these formulas is that, one, I want to be able to talk about how to get between them. And two, if you're given a piece of information, like if I tell you what the vertex is and another point, then going to the vertex formula is going to make your life the easiest. Right? If I tell you what the two intercepts are and another point, you want the factored form. If I just tell you 3 points, maybe you'll want this guy and to solve for A, B, and C. You guys see that? So depending on the information you're given, it's nice to have one or the other of these. Questions on how to get to the vertex form? Like if you start with standard form, how do you get to vertex land?
You factor it out and then what?
You graph it and
You could graph it and try to figure it out, yeah.
that's the only way.
How would I get from vertex land back to quadratic, back to standard land?
I would have to graph it.
Can't you filter it? Can you filter the A back?
Like, so if you started with this, how would you get to ax squared plus bx plus c?
Well, factor would be ax minus, or
You have to
x squared.
FOIL first.
Yeah, just freaking multiply it out, right? So FOIL, combine like terms. Okay, now, and this is hard because I know this is a skill that you all have lost from Algebra 2. How do you get from a standard form to a vertex looking thing?
And you're saying
It's
you can't
not factoring. It's related.
You complete the square.
Yeah.
Which means that you subtract the c from both sides, and then you like figure out what c would be for this.
Yeah, so we
Something
teach you guys to solve equations by completing the square, right?
Yeah.
We don't really teach you to go backward,
Right.
right? Like, we don't teach you to change forms with completing the square. So the changing forms with completing the square is just like a varsity move here. And I'll show you guys how to do that, okay? But I want you to know that to get from either of the other two forms to standard, you just multiply that out, combine like terms, and you're done. To get from standard to factored, you factor, surprisingly enough. And to get from standard to vertex, you complete the square. Cool? And then the other thing I want you to know is that vertex form is the like, hey, I know what the vertical stretch, the right, and the up are. Right? Like, I know shifting rules. So if I can get it into vertex form, I know exactly how to graph it easily. That's cool? Okay. So, what are your... Oh, maybe I should give you examples for all these things. Let's do an example. Let's see if we can figure out how to get q of x is 3 times x minus 1 times x plus 2. Can I get that into standard form?
Yes.
Okay, how do you do it? What do you get?
Well, and combine it.
FOIL and combine like terms. So what do you get? You get q of x is,
X squared
Let's
plus
see.
X
so we got
minus 2.
x squared plus x minus 2 when I FOIL that stuff out.
So back to, you didn't have to.
And then I have this
multiply by
3. So I got 3x squared plus 3x minus 6.
So, yeah.
All with that?
Yeah.
Okay. Can I complete the square on that?
I don't remember how.
Okay, cool. All right. Should we try to remember how?
Yeah.
I'm going to make a separate video for that.